equation is what we're looking for here. What do we got? X equals, it sure is. It sure is. Coordinates of the vertex?
1, -10.
Boom shakalaka is what we say to that. Interval where the graph is increasing, so going uphill.
Hard 1, infinity soft.
Hard 1, infinity soft, exactly. All right, starts at 1, and we can never capture infinity, so we can't put the hard bracket on that. Exactly. Decreasing.
Soft, infinity 1 hard.
Infinity 1, soft.
What's that set?
Nah, I said.
I said soft, infinity 1 hard. Soft, these are one syllable words though.
I'm just enjoying all of this. It's just so great. Just the whole interaction, like getting hung up on the name of it, like it matters.
That is a soft bracket and a hard bracket.
Yeah. Or a square bracket, a round bracket, or squiggly, parentheses, brackets, or
soft and hard.
or one of these and not one of those. Like honestly, at the end of the day, one includes the value, one doesn't. So the square one, it allows you to get to the one. The round one say that you'll never actually get there. All right, so the standard form of a quadratic, also known as a vertex form. Adios. All right, so that's the form y equals a times x minus h squared plus k. You don't even know it. How can you say you hate it? You just met it.
I thought it was like the AB one.
There is an AB one. This is
standard form?
different.
Yeah, it is.
That's actually the general form.
Oh.
Oh.
So close.
I had this up earlier, but it makes sense to talk about it now because people look at this and say, okay, now you're just going out of your way to make this more challenging than it needs to be. There is value to this form because within this form, you actually have the vertex. That's why another name for it is called the vertex form of a quadratic. So the h and k values are actually the vertex of the parabola. All right. So if you ever have a parabola written in this form, or you can get it into this form, then you'll automatically know what your vertex is.
Wait, why would it have 2 vertexes?
Some functions actually have more than one vertex.
Oh, so it'd be like,
Yeah.
But can't you just find the vertex just by looking at it?
Sometimes, but sometimes the numbers are hideous.
So if it's like this, then wouldn't there be 3 vertexes?
There would be 3 vertices, and that would be a 4th degree equation. So you'd be dealing with something that's raised to the 4th power.
How could you have 2 vertices though?
How could you have just 2? Let me see if I can visualize.
One. What?
Because if it were to go in the same direction, it has to be symmetrical.
Exactly.
So?
Oh yeah.
So if they start and end in the opposite directions, yeah. Right, and that's an example of a cubic model. But we get a little ahead of ourselves. This is something that is a direct consequence of completing the square, which is good because, actually it depends on your perspective, I guess, but we spend so much time practicing completing the square where it's like, well, don't you want to put it to good use? Of course you do. I don't know that you actually agree with that, but most of the time people, it's complicated, let's put it in a rear view mirror, but I look at it the other way. I look at it, we better be learning this for a reason. It's complicated, I want to put it to use, So the axis of symmetry would be x equals whatever the h value is, and the vertex is h comma k. All right. There's other ways to do this because we also know that the axis of symmetry is x equals negative b over 2a. The issue with that is I don't see no A's, well, I see an A, but I don't see any B's in my standard form equation. You know, so this one doesn't quite fit what we're doing here. But if you're given an equation in its general form, you could use negative b over 2a instead of this approach. But I want to familiarize you with the approach to get it into standard form because there's value to it. All right? The reason why it's called standard is because it is a standard approach no matter what function you're dealing with. It could be linear, quadratic, cubic. You could throw a quartic function in there, which is a power of 4. You could get into trig functions, exponential functions, logarithmic functions, so types of functions that we're going to learn about down the line. They can all take on this form, so there is consistency. Anytime there's consistency, there's familiarity. Familiarity means less stuff to study, in my opinion. All right. So let's practice with at least a couple of problems, time permitting, and see where this takes us. All right. So axis of symmetry and the vertex. Now, looking at the question, it doesn't say to do it in any particular way, so that's always something to keep in mind. I expose you to a variety of different approaches. In this circumstance, you get to choose which one you like, and then go with that. All right. In the last unit, it was you had to learn factoring, completing the square quadratic formula, and you had to demonstrate knowledge in all three. For this topic, I'll show you both methods. Well, I'll show you one today and one tomorrow, and then you can pick which one you like more. All right. So here, I'm going to apply the completing the square technique. If I'm going to do that, and the presence of the y tends to throw things off a little bit, at least conceptually, but it's still the same idea. I'm going to get rid of the 7. I'm going to add it to both sides. So I'm looking at y plus 7 equals x squared plus 4x blank, because I need to complete the square. All right, you want to get to a point eventually, maybe you're not there yet, but you want to get to the point eventually where you're doing the completing the square part of it in your head. All right, so what is the formula for that again? B over 2 squared. So this part of it down the line should be something that calculation is happening in your mind, not necessarily on paper. But it's still Algebra 1, so let's do it out by hand, you know? All right? You're not expected to do all sorts of complicated math in your head just yet. All right, so 4 over 2 squared would be what? 4. As calculations go, that wasn't too bad anyway. All right, so left-hand side becomes y plus 11. Right-hand side, that's going to factor. What is it going to factor to? X plus 2 squared. All right, so far very similar, except for the fact that y is there, to the completing the square approach to solve for roots. Normally at this point we would take the square root, but if our goal here is to write it in standard form, the only thing I have to do at this point is get y by itself. Subtract the 11, and that's it. So y would be equal to x plus 2 squared minus 11. So from this, I can get my vertex and my axis of symmetry. They asked for the axis of symmetry first and then the vertex.
Oh,
I like getting the vertex.
Putting it into standard form.
Correct. And then from the standard form, we can state the vertex. What would the vertex be? Just look at the relationships above.
Negative 11.
That's part of it.
Negative 11.
Very close. Not positive 2. Negative 2, exactly. And this little stray mark just showed up out of nowhere. Negative 2, negative 11. All right, so just think about that for a sec.
Wait, so would we plug it into the equation?
No, we're pulling it out of the equation.
You have to memorize the standard form.
Yes.
Oh, because we have like 11 is in
That's
this,
what I'm
negative
getting, yeah.
11 is k because it's positive, it stays negative 11, but you have negative h is a positive 2, so it goes
Correct.
negative 2.
I'm going to reiterate that for
So many
everyone.
letters.
So the formula itself is x minus h. All right, so I'll just rewrite it next to it. Y equals a times x minus h squared plus k. All right, so somehow the negative h became a positive 2. In order for that to happen, negative had to become positive, which means I had to have plugged in a negative number. right? So that's where the negative is coming from, right? So in order for a negative h to become a positive 2, it must have been a negative 2 substituted in there. If you're ever really nervous about this, all you have to do is take those two parts, the positive 2 and the negative h, and set them equal to each other and solve for h. H would be equal to negative 2. You do the same thing for the k, except it's a little easier to see. If I want to make k into a negative 11, what do I do? Replace k with a negative 11.
Would h always be a negative?
H will always be the opposite sign of whatever is on the
If we have
inside.
x minus, but we couldn't get x minus 2, right? Because
You could if you put in a positive 2 for h. Because then it would be x
Yeah, but
minus.
through completing the square, right? You wouldn't be able to through that method.
You
right?
could, if this term is negative.
Oh yeah, I don't know what
All right. So my axis of symmetry comes from the vertex. That's why I did the vertex first. So my vertex is negative 2, 11, negative 2, negative 11. What's my axis of symmetry? X equals negative 2. It's just the x value of your vertex. All right. So if your equation's in the appropriate form, you have everything you need. And I'll show you down the line how to create the graph just by knowing this equation. If you know this equation, very easy to create the graph. Time check, 7 minutes. All right. So let me do one a little beefier. This one's got a leading coefficient. But just like when we were learning about completing the square, yeah, divide by the 3. Same approach. Divide everything by the 3. Yeah, we'll get some fractions. That's fine. Calculators exist. All right, I need to vacate the 1/3, right? I need to get that out of there. So I'm going to subtract it off. That doesn't look as nice, but it's still the same situation.
Wait, since they have a common denominator, you can do y minus 1 over 3, right?
You could, but it's going to be easier if we leave it like this. All right. So I need to complete the square. So again, a b over 2 squared. What's that going to be?
9.
And 9. Add 9 to both sides. I'm going to need negative 1/3 plus 9.
Negative 28 thirds.
Close. It's the right idea. 26 thirds, yeah. And it's positive, right?
Oh.
And the right-hand side factors to what? Yep, or do.
Can we add back the 26?
Subtract it off.
Yes, yes.
The only goal at this point is just to get y alone. All right? So that's the only thing you got to keep in mind, is that my only responsibility here now is to get y by itself. And if you do that using appropriate orders of operation, then you'll be fine. So we're subtracting off the 26 thirds.
Multiply by 3.
And then after that, we'll multiply by 3. So y over 3 is equal to x minus 3 squared minus 26 thirds. And then again, as you said, we're multiplying by 3. All right, so on the left, it just becomes y, right? We're multiplying each part by 3. So the binomial gets multiplied by 3. I'll just put coefficient of 3 right in front. And what's negative 26 thirds times 3? The negative 26. My thoughts exactly. All right, and what is my vertex?
Negative 3.
3, negative 26. And my axis of symmetry?
3.
X equals 3. All right, axis of symmetry is a vertical line. Vertical lines are always in the form of x equals. All right. I don't like making trick questions on tests because they're just mean. But since the Regents is going to do it, I have to do it to prepare you for it. So you're going to take a test and you're going to have a problem like this that asks you for the axis of symmetry. You know one of the choices is going to just say 3. Right?
Instead of x equals 3.
And another choice is going to say y equals 3. And another one is going to say a equals 3. Right? So you got to know it's x equals 3. Pizza.
Is there a program in the calculator for this?
There is an approach in the calculator. It's not a program, though. But we will go over it. The issue with the calculator is that sometimes you can get bogged down on the fact that decimals are a thing, and the approach in the calculator is really good with whole numbers, but not necessarily decimals.
So since the h is negative, you just flip like whatever number.
Whatever the sign is on the inside, yeah.